Hi everyone, this is the second episode of the See You in Guangdong live streaming series. Today we have invited Dr. Larry Crowder from Stanford University to talk to us about sea turtle protection. And we know that you're an expert on sea turtle, so we're lucky to have you today to talk to us. I think we can all agree that global warming is like a huge factor affecting a lot of endangered plants and animals. And can you just tell us a little bit about how global warming is affecting, the living condition of wild sea turtles, including like their migration patterns and their reproductive habits, etc.?
Yeah. Well, the most obvious problem is that sea turtles don't have sex chromosomes like human beings. The sex of the hatchlings is determined by the temperature of the beach. And so it varies from turtle species to turtle species. But for example, for loggerhead sea turtles, if the temperature is above 29 degrees centigrade, it produces females. And if it's below 29 degrees centigrade, it produces males. And with climate warming, what we've seen in large parts of the world is where the turtles have historically nested and produced maybe half males and half females, they're now producing 90% females or 95% females. In Florida, where the largest loggerhead population is in the United States, it's currently so hot that it's been producing 95% females. And I talked to one of my colleagues there just a few months ago, and she said, well, it's kind of worse than that. It's gotten so hot that the embryos are like cooking in the sand. They're dying from the heat. And so warming beaches lead to a skew in the sex ratios. And, turtles don't mate for life or anything like that. So a male can mate with multiple females. But at some point, males become limited and females just don't have access to a mate. And what they do then is go up on the beach and lay eggs that aren't fertilized. So temperature can be a really important issue in that part of the life history. How do turtles adapt to that? There's evidence for a lot of turtle populations that they're starting to nest earlier in the year. Like they usually nest in late summer, and where it's really been warming up, the dates that they start laying eggs are moving earlier on the calendar. So maybe they used to start in May and now they start in April. And that means that the eggs are exposed to cooler beach temperatures. The other thing that happens is that turtles are moving toward the poles of the earth. So turtles, they're tropical turtles. But if the beaches are too warm, they may start to nest more further north in the northern hemisphere, further south in the southern hemisphere, and that means the beaches that they're depositing their eggs in are cooler. And so we can expect to see changes in how the turtles use the ocean and how they migrate, but particularly shifts in time or space where nesting occurs, to try to keep the sex ratios more reasonable. And we know that we're seeing this highly skewed sex ratio, and the turtles seem to be responding to it, at least where I've studied, they seem to be responding to it, but it's kind of slow. Like they aren't moving north rapidly, they aren't moving earlier rapidly, and there's a lot of year-to-year variability in how temperatures are expressed.
Mm-hmm. You mentioned that in Florida, 95% of the eggs were like female. So does that mean like human intervention is needed or necessary in this process, to balance out the
Yep.
section?
Well, people have proposed that, and you can engineer like shade on the beach above where the turtles lay their eggs, but you're talking about hundreds of miles of beach, right? So if you could keep the sand cooler, you could shift toward producing more males, and you can do that at a small scale. Like you might put up some kind of shade cloth above the beach to keep the sand temperatures cooler in the sun, but you can't do it at the scale of the turtle nesting. I mean, it's hundreds of miles of nesting beach. If you had a turtle species that just had 1 mile of nesting beach, or they nested in a pretty narrow area, then you could intervene by shading the turtles. Some people have intervened by, when the female lays the eggs on the beach, they actually take the eggs out of the nest and move them up the beach someplace else. Like in the tropics, you can take eggs from the open beach in the sun and move them up under the palm trees, and the natural shading from the trees will keep the nest cooler. We don't know how those interventions work in the long run, but it's pretty desperate, right? And when you have these huge sex ratio skews, and when sea turtle embryos are actually cooking in the nest, you have to do something. And turtles seem to have some adaptive capacity to nest earlier or to nest further north. In North Carolina, for example, when I was working, not very many turtles nest in North Carolina, so they haven't thought about protecting those beaches. But those beaches are where all the males are produced, the whole population. And I'm expecting with climate change, more turtles are going to nest up there and fewer turtles are going to nest in Florida, because turtles have been around for tens of millions of years. So they have evolved strategies to deal with this kind of variation, at least at a year-to-year scale.
And so in addition to like global warming, what other factors are kind of affecting the way they live?
Yeah, well, because sea turtles come to us to nest, people have paid a lot of attention to human impacts on nesting habitat, like driving on beaches can damage nests, lighting on beaches can distract hatchlings from finding their way to the water. So there are a lot of interventions that humans do, developing housing or touristic developments, which can change the beach profile or the beach lighting patterns in a way that are harmful to the turtles. But compared to accidentally catching turtles in fisheries, those beach lighting things seem to be minor, because sea turtles over their life history, each female produces tens of thousands of eggs, and 1 or 2 of those become an adult. So protecting the eggs doesn't have the same payoff as protecting a teenage turtle or a turtle in their 20s that's in the water, because that female that's in her 20s is just a few years from being a reproductive age female. And if they're scooped up in a bottom trawl or caught on a long line or caught in gill nets, that's really devastating to the population. And one of the things we learned about that applies to all sea turtles is that if you're going to protect one turtle, and that's all you can protect, the answer is protect an adult nesting female. She's like ready to contribute to growing the population. But if you can protect a stage, like a certain age group of turtles, protecting the large juveniles and subadults is really important, because they're close to being adult sized. And there's a lot of mortality of large juvenile and subadult turtles in fisheries. And so this issue is called bycatch or unintended catch. In most cases, the fishermen aren't interested in catching the turtles. Historically, there have been fisheries that target turtles, but in most parts of the world, the fishermen don't want to catch the turtles. They just accidentally catch them when they're trying to catch finfish or sharks or something that they're trying to sell. So I think the bottom line is that mortality in those later stages, usually related to fishing, is the #1 threat to turtles. And it's a difficult problem to solve, because in large parts of the world, the fisheries are economically important. They create a lot of jobs. And when you make the case that we should restrict the fishery somehow to protect the turtles, you get a lot of pushback politically, as you might expect. So there are conservationists who want to protect the turtles and fisheries people who just want to assume the problem away.
Because sea turtles are trying to adapt to what's happening on Earth, like such as global warming, and they might nest further north. But something I learned from sea turtles is that they, during the nesting season, they actually go back to their birthplace and nest on the beach they were born. So how does that work if they're like moving further north and they're not going actually?
That's a problem. You're absolutely right, because turtles do tend to return, if not to the beach where they were born, to the region that they were born. And so if for example, a loggerhead sea turtle that was born 50 years ago on this beach in Florida returns to nest repeatedly to the beach in Florida, but their hatchlings don't survive, then the turtles that were born further north, their hatchlings are going to survive. And over a long period of time, the population will gradually shift. But the other thing we found when we put satellite tags on female turtles and watch them with their first nest and second nest and third nest and fourth nest and fifth nest in the same season, they don't come back precisely to the same beach. They move around. Like these loggerheads in Florida, they nest in Florida, but they nest over a 400 or 500, 300 or 400 mile range. And so they kind of, if you think about the evolution of these sea turtles, they could lose all their hatchlings to a flood or a storm. So by putting their eggs in different places, but in the same region, they reduce the risk of losing all of their hatchlings. So there's a little bit of variation in the actual behavior of turtles. They don't go back, like you see on the television specials, to the beach where they were born. And that wouldn't be a very adaptive. Like what happens if, 30 years later, you go back to the beach where you were born and it's just gone. Like, it's been washed away in a hurricane or something. I assume they don't just say, well, gee, I'm out of luck. They move someplace else and find a beach which looks suitable. So I think that is a risk, because turtles do have a strong tendency to return to the region where they were born. But over time, more turtles will be successful from beaches that are further north than beaches that are further south. I mean, if all the turtles, the eggs that are being deposited in Florida simply cook because of the heat, then the turtles that survive are going to be those that are further north. And their hatchlings will come back as adults 30 years from now in a place that tends to be cooler. 30 years from now, if that's the age at which they first mate, that's a long time compared to how fast climate is changing, right? So humans have to think about whether there are practical ways to intervene.
Are there any successful examples of like how fisheries are trying to, avoid having sea turtle bycatch?
Well, there are some very successful examples, and probably the one which I think is most successfully documented is in trawl fisheries that are they're pulling nets across the seafloor to like catch shrimp or fish. If they pull those nets to catch shrimp through an area where there are sea turtles, the sea turtles get caught in the bag of the trawl, and the trawl's down for a couple hours. So the sea turtles just drown in those trawls. Way back in the 1990s in the US, the agencies developed something called a turtle excluder device. And it's basically a grid that goes into the back of the trawl. So when the turtle comes back in the trawl, it slides up this grid and out an opening in the mesh at the top. So the shrimp go right on through the bars to the bag that retains them, and the turtles slide up this excluder and can get out of the trawl. And based on what I told you about the life history, if you could save a stage, it's the large juveniles and subadults. It was the large juvenile and subadult Kemp's Ridley turtles and loggerhead turtles that were dying in shrimp trawls in the Gulf of Mexico by the tens of thousands per year. So when we showed that that's the stage you should act on to recover the animals, and It was some work convincing the fishermen to try this, which is a long story that we can go into later. But the fishermen did adopt them like by the mid-1990s. And the Kemp's Ridley sea turtles only nest in the Gulf of Mexico. And in 1986, they were down to 800 nests. That's about 300 females in the entire population. And after turtle excluder devices went in place, they've come back, and now it's 40 or 50,000 nests a year from 800. And the loggerheads in the Southeast were declining at 5% a year. Now they're increasing at about 3% a year. And that is directly attributable to these excluder devices, which allow the turtles to get out of the trawls. And people have worked on similar gear modifications, trying different gear modifications for longline gear and for gill nets. It's more complicated to come up with a technological fix for long lines, but some people have switched from J-shaped hooks to circle-shaped hooks, where the barb of the hook goes in toward the hook, and it goes down the turtle's throat. The J-shaped hook catches in the esophagus and tears the turtle's esophagus. The circle hook goes down and comes back up without doing damage. So there are some gear fixes which can reduce sea turtle mortality, and all of those have been tried in multiple fisheries and been adopted to various levels. One of the new things that's being discussed is something called dynamic ocean management. And that comes from having the scientific capability to put satellite tags on sea turtles and develop mathematical models for where they go under different oceanographic conditions and where they aggregate. And so if you can model the distribution of the sea turtles and look at the distribution of the fishery, you can look for when there are likely to be conflicts, if the fishermen are exactly where the turtles are, and where they're not likely to be conflicts. So if you can redirect the fishery to where the turtles are not, they don't need to modify their fishing gear, right? They don't need to use circle hooks. You just move the longline fishery to a place where they can still catch their target species, but the risk to turtles is low. This idea is only about 10 or 15 years old now, but we have the technological capability to model these threatened species and to model or monitor how the fishermen move around. And one case that's directly sea turtles is in the North Pacific. The sea turtles accumulate in something called the North Pacific Transition Zone. There's cold Arctic water from the top and tropical water from the bottom, and there's a zone between those where all the food accumulates, and the tunas and the sharks and the turtles are all in that zone. If the fishermen set their longline hooks in that zone, they're going to kill a lot of turtles. But if they set their longline hooks north of there, in slightly colder water, they can catch swordfish and no turtles. If they set south of there, they can catch tunas, but no turtles. And so basically, this is a product that's produced by the National Oceanic and Atmospheric Administration that puts onto a nautical chart for fishermen. This is where the zone is where you should not set your gear because you're going to catch turtles at too high a level. You can fish north or south of there. And of course, that area moves seasonally. In the north, it's 1,000 kilometers further north than in the summer than in the winter. But you don't have to close the whole Pacific Ocean. You just close that feature that the turtles are in. And so it would be, you've heard about marine protected areas, right? If you're going to protect a coral reef, you can draw a line around it and restrict what people do around the coral reef. If you're going to protect turtles, because they're in the open ocean and they're in these dynamic features, you have to have mobile marine protected areas, not static marine protected areas, right? And that's a really new idea. Scientists are exploring, but it's already been picked up in a number of different management realms. And the fishermen at first don't like it when scientists suggest they change what they do. But in this case, we're saying you can fish the same way you've been fishing. We just want to steer you to places where you're not going to have a large number of turtles. So the government's not on your case or trying to shut you down for killing turtles. You just fish in a place where the turtles are not. And that, the fishermen are at first skeptical, but after they actually engage in this, they say, so I can still make a living unless the target of the fishery is exactly where the turtles are. You can find a place that's relatively safe to fish and protect the turtles. So for the United States flagged longline vessels, they have to use this turtle watch program and respond and not set in that area. The international boats don't have to respond to U.S. rules, but the U.S. boats have to. And in that case, what they did was the U.S. fleet was advised to stay out of this convergence zone, which is mapped every day. And for the entire fleet, they had a total bycatch limit, like pick a number. The fleet can take 40 loggerhead sea turtles over the whole season. And so when they get to 40, the fishery gets shut down for the year. And so the fishermen go out there and they set in this zone where the turtles are, and they kill 10 turtles, and now they've only got 30 left. And then they only have 15 left, and then they only have 10 left. And the fishermen have adapted to try to stay below that 40 turtles allowed so that they can keep fishing, right? It's not a gear fix. It's considering that the fisheries dynamic, it moves around based on its target species and the changing ocean conditions, and the turtles respond to changing ocean conditions. And 15 years ago, the first paper that was published suggesting this idea was almost 30 years ago now. And I read the paper and I said, this is a really cool idea, mobile marine protected areas, dynamic ocean management, but we can't do it. We don't have the scientific capability to do it. Now we do. So when I first read the idea, I thought, this is a wonderful idea, we can't do it. And over the last 15 years, we've begun developing that technology and using existing technologies to open the door to dynamic management. And my prediction is over the next 10 or 15 years, it will become very common. It ends up, what it requires is a really even-handed, fair conversation between the fisheries and the environmental advocates and the government agencies and the university people, because there's a lot of pressure put on by the environmental NGO community to make a quick decision, and they're happy to shut down the fishery to save the turtles. And the fishermen, of course, are fighting back, saying, but we've been making a living out here for a long time, and there are people who depend on this resource and all that kind of stuff. And they ends up going to court and having battles and all that kind of stuff, which is kind of an arm wrestling approach. But the government makes the decisions and does the enforcement, so the government has to be involved. And I think the role of universities is to say, it doesn't have to be one team wins and one team loses. Maybe we can come up with a win-win solution that works for the fishermen and works for the turtles. And so the whole notion of marine conservation and sustainability now is that you want to come up with solutions that work for the people and the planet, not just for the turtles, and don't worry about the people, or not just for the people, don't worry about the turtles. There are ways now with gear modifications like turtle excluder devices. They've been required in the US for over 30 years, and it also went international. So if you want to catch shrimp and import them to the US, you have to document that you have turtle excluder devices required in your fishery.
So we don't have much time left. I would just like to ask one more question about our live streaming. Like, I don't know if you've seen this kind of live streaming program before, and what do you think this kind of media efforts will do to raise public awareness?
World we live in, everybody's live streaming on their phone, right? Not just at a screen on the desk. And so I think it's incredibly powerful. There are so many people who don't understand or appreciate nature because they don't get out into nature. Like if they're urban people, who gets to see corals spawn unless you're a scuba diver and you happen to be there at the right place in the right time. They don't spawn all year. They don't spawn every time you go out there. And so giving people an opportunity to experience nature and inspire them, the old phrase is, right, a picture's worth 1,000 words. A movie's worth 1,000,000 words, right? The streaming is way more than a still photograph. And so I think it's very powerful, and I applaud your efforts to do that. The whole idea of live streaming a good story, I think, does capture people's attention. And people are so isolated from nature these days that anything that gets them, like, it wouldn't be better than being in the water to watch the spawning, right, of the corals. But if you're not going to be in the water watching the spawning, seeing a live stream is really impressive. And the video that you all got was beautiful. It was colorful. It was active. It was, a sensory, very sensory kind of event. And so the whole idea of live streaming and storytelling, I think, is, that live streaming is worth 1,000,000 words, not a picture's worth 1,000 words. So I totally think the approach can be very successful, and I wish you all the best.